Welcome students, welcome to the video class. Today we will start a new chapter, that is magnetism. ठीक है जी? तो हमरो बोर्ड रे अराउंड शॉर्ट क्वेश्चन भी आसे यार लॉन्ग क्वेश्चन भी आसे. It's a easy section. Okay, let's start. So what is a magnet and what is magnetism? Okay, magnet is a substance. Magnet is a substance. These substance attract iron or iron-like substance towards itself. Again, magnet is a substance which attract iron, cobalt, nickel-like substance towards itself. इटा गोटे substance जे कि iron, nickel और cobalt-like substance को attract करे निजोड़. Even that magnet has a tendency to always remain in north south direction. से सदाळे कोन हो जदि हम फ्रीली सस्पेंड करियो तो इट ऑलवेज रिमेन इन नॉर्थ साउथ डायरेक्शन. ठीक है. डेफिनेशन पढ़ियो. A substance which attract iron, cobalt and nickel etc like substance towards itself is called a magnet. So magnet is a substance which attract iron or iron like substances. And we can also say a magnet is a substance that has both attractive, because it attract iron, nickel, cobalt like substance towards itself, and directive properties. Directive means just I have said कि यदि এটা freely suspend करे it always remain in north south direction, so it has directive property. ठीक है. Then what is magnetism? Magnetism is the property of the magnet. Again, magnetism is the property of the magnet. The property is it attract iron, cobalt, nickel like substance towards itself. Again I am saying magnet is a substance. Magnetism is the property of magnet. Again, magnet is a substance and magnetism is the property of the substance, that is magnet. What is the property? It attract iron, cobalt, nickel like substance towards itself. Okay, so the property of attracting iron, cobalt, nickel like substance towards itself is called magnetism. ठीक है. तो magnet is the substance, magnetism is the property. Magnetism is its property. ठीक है. So this magnet and magnetism was known to men as earlier as 6th century. So Greek people know this property. So as early as 6th century BC, the Greek had some knowledge of magnetism. They knew what is magnet and what is magnetism. Thales of Miletus knew that pieces of naturally occurring iron ore, lodestone or magnetite has the property of attracting some piece of iron. So this Thales of Miletus know that limestone or lodestone or magnetite has the property of attracting iron pieces. And after that, this Chinese people, they discovered that when a lodestone is suspended freely, it always remain in north south direction. Again I am saying, these Chinese people, after this Greek people, they knew that or they discovered that when a lodestone, when suspended freely, it always remain in north south direction. And that in 1000 AD, even the Chinese people are using this magnet for navigation in ships. So ship re jaante, they used this magnet for this navigation purpose. Next we will discuss types of magnet. Magnets can be of two types. One is natural magnet, second is artificial magnets. The magnets which are found on earth crust are called natural magnets. Magnets जोटा कि हमें earth crust रे पाऊ, that type of magnets are called natural magnets. सेमानंको पाखरे permanent magnetic property थाए. The magnets which we found in earth crust have permanent magnetic property. That example of natural magnets are, this is lodestone or this magnetite. ठीक है. Again, out of कि in our daily life and in our industries, in our electrical devices, electronic devices, we use different magnets. Sorry, we use lots of magnets of different sizes and different magnitudes. Again, in our daily purpose industries, electronic and electrical devices, we use magnets having different magnitudes and different sizes, shapes, and for that we produce magnets. Good example now. So let us take a iron piece. सेटा को गोटे मैग्नेट नहीं कि रब करियो. अगेन गोटे आयरन पीस नबा आ गोटे मैग्नेट नहीं कि ताको रब करियो. आफ्टर रबिंग फॉर सम टाइम हम देखियो कि it has acquired the property of magnetism. Again, after rubbing some time, the iron piece acquired the property of magnetism. Just like that. So we produce magnets by taking magnetic substances. What are magnetic substances? These are iron or iron-like substances. Iron or iron-like substances are magnetic substances. And these are made to acquire the property of natural magnet. They are made to acquire. They are made to acquire the property of natural magnet. And these magnets can be more powerful than the natural magnets. Artificial magnets can be made more powerful than natural magnets. आमे last किछटा वीडियो रे पढ़ी थिले a solenoid. When we supply current to the solenoid, it acts like a bar magnet. If we supply more amount of current, the magnitude of magnetic field produced by the solenoid or that bar magnet is more. So that means by increasing the current, we can make a bar magnet more powerful, or a solenoid or the bar magnet more powerful. Even we can change the pole position by changing the direction of current. Okay, so this is an example of this artificial magnets. Okay, some examples of this artificial magnets are bar magnet, janichu, and magnetic needle. These are used in compass, and horseshoe magnet. It horseshoe pari dekha jay, that's why they are called horseshoe magnet. Next we will move to properties of magnet. Okay, next is basic properties of magnetism. First property is attractive property. We know that a magnet attracts iron and iron-like substance towards itself. So it is the attractive property of the magnet. Again I am saying, we know that the magnet attracts iron, cobalt, nickel like substance towards itself. So it is the attractive property of the magnet. ठीक है. तो जदि गोटे मैग्नेट को हमें आयरन फीलिंग्स, तो let us consider a magnet which is placed in a heap of iron filling. Heap means gada. Iron filling means gunda. आयरन रो गुंड तो जदि गोटे गदा अछि आयरन फिलिंग रो एंड तापर जदि हम गोटे मैग्नेट को रखिबा तो we will see that the iron fillings are more attached near the poles. So we can say the concentration of iron filling is more near the pole as compared to the central part. Central part कम अच्छे and near the pole it is maximum. So we can say from this कि the attraction is maximum near the poles. That's why large number of iron fillings are attached near the poles, and the attraction is minimum at the central part. That's why very less number of iron filling are attached. Next we will move to the second property, that is like poles repel each other. If you take two similar poles, let us say north north. So if you take north north together, so like poles, they will repel each other or they move away from each other. Similarly यदि हमें कौन करिया साउथ साउथ रखिबा तो they also repel each other and they will move away from each other. So we can say like poles repel each other. Similarly the unlike poles naba, they will attract each other. ठीक है, तो like pole repel each other, unlike pole attract each other. ठीक है. Next we will move to the third property, directive property. What is directive property of magnet? जदि हमें गोटे मैग्नेट को freely suspend करिबा, it always remain in north south direction. Again, जदि हमें गोटे मैग्नेट को freely suspend करिया from a rigid support, it always remain in north south direction. Okay, then why it remains in north south direction? बुझियो, actually if you consider earth, जदि हम earth को consider करिया तो earth रो geographical north एटा and this is the geographical south. This is the north, this is the south. Actually earth itself is a huge magnet. Earth itself is a huge magnet having south pole at geographical north. South pole at geographical north and north pole at geographical south. बुझलो? Again I am saying earth itself is a huge magnet having south pole at geographical north of earth and north pole at geographical south. ठीक है, that's why जदि हम गोटे छोटो कंपास नबा, let us say this, तो एटा जदि नॉर्थ एटा साउथ of the compass, the north will be attracted to the south pole of the earth magnet. Again, the north pole of the compass will always be attracted towards the south pole of earth magnet, and the south pole is always attracted towards the north pole of earth magnet. That's why se सदाळे north south रुहे. That's why the magnet or the compass always remain in north south direction due to the attraction of the earth magnet. बुझलो? Again I am saying earth itself is a huge magnet having south pole at geographical north and north pole at geographical south. जदि हम गोटे कंपास नवा तो the north pole of the compass will be attracted towards the south pole of earth magnet, and the south pole of the compass will be attracted towards the north pole of the earth magnet. That's why they will move like this, or the compass always remain in north south direction due to the attraction to the earth magnetic field or earth magnet. ठीक है. Next property is magnetic poles always exist in pairs. Again, magnetic poles, that is your north pole, south pole, they always exist in a pair. ठीक है. So let us consider a magnet having north pole and south pole. जदि एटा को मझिरे मु ब्रेक करिवि तो what happens? तो जदि एटा को मझिरे ब्रेक करिवि, we will get two magnets each having a pair of north pole and south pole. जदि आउ थ्री मु ब्रेक करिवि, तो जदि मु आउ थ्री मानु को डिवाइड करूछु, we will get four magnets each having a pair of north pole and south pole. So we can say a magnet always exists in pair. If we jette part kole madhyo, they always remain in pair till molecular level. Again I am saying, if you divide the magnet, it means in any parts, jette part re divide kole madhyo, the magnet always exists in pair, that is north south pair. बुझलो? This will continue till the molecular level. बुझलो? So we can say magnetic poles always exist in pair. और आउ गोटे जिनस आम कहि परिया, monopoles never exist in magnet. magnet रे single pole possible नहीं, तो monopole never exist. आमे magnet रे single pole कहि परिबनी, they always exist in pairs. Which again I am saying, in magnets we cannot say, so you cannot say the magnet is having a single pole, or monopole never exist in magnets. They always exist in pairs, that is north pole and south pole, a pair of north pole and south pole. Next is magnetic induction. What is magnetic induction? I mean electrostatic induction पढ़ी थी. So let us say this. Let us consider a magnet, that is, जदि ए magnet पाखरे गोटे soft iron piece आनिबा, तो due to this magnet a soft iron रे एठी गोटे south pole induction होबो and opposite side रे north pole. Due to this induction, तो एठी कोन होला, due to this कोन होला, soft iron रे this the poles are induced. So that induce होबो, north pole of the magnet will attract the south pole. That's why this soft iron will be attracted towards the magnet. This soft iron is attracted towards the magnet due to the induction. बुझलो? Again I am saying, let us consider a magnet brought near a soft iron. तो जेतोले magnet टाकू soft iron पाखरे अना जिवो, तो due to this magnet a soft iron रे near the north pole of the magnet south pole induce होबो एंड ऑपोजिट साइड रे नॉर्थ पोल तो एठी ऑपोजिट पोल्स अछंती तो unlike pole attract each other that's why the soft iron is attracted towards the magnet due to this induction of north pole and south pole in the soft iron this is called uh, magnetic induction बुझलो next is some definition connected with magnetism okay first is magnetic poles we know that a magnet always exists in pair that is a north pole and a south pole a north pole and a south pole so if you consider the magnet जो poles था that is north pole and south pole से magnet रो face रू टिके भीतर था this is the face of the magnet a face रू टिके भीतर को था the poles are slightly inside the face रू face of the magnet रू टिके भीतर को था बुझ लगे the north pole and the south pole जो थांती से माने जो face of the magnet रू टिके भीतर को थांती ठीक है second is magnetic axis the line passing through the north pole and south pole is called magnetic axis again the line passing through north pole and south pole or the poles of the magnet is called magnetic axis next is magnetic equator the line passing through the center of the magnet and perpendicular to the magnetic axis is called magnetic equator the line which passes through the center of the magnet and perpendicular to the magnetic axis is called magnetic equator passing through the center and perpendicular to the magnetic axis the line passing through the center and perpendicular to the magnetic axis is called magnetic equator ठीक है next is magnetic length so again outside here got a magnet number so let us consider this magnet these are the two faces of the magnet these are the two faces of the magnet the distance between the two faces is called geometrical length and the distance between two poles is called magnetic length again the distance between two faces of the magnet is called geometrical length and the distance between two poles of the magnet is called magnetic length and it is proof that the magnetic length is 0.84 times geometrical length okay again the magnetic length is तो एठी कोन होला geometrical length टा अधिक अछि and magnetic length टा कम अछि काहे कि the pole reside slightly inside the magnet face ru टिके भितर को थांती so the magnetic length is smaller than the geometrical length so it is proved that the magnetic length is 0.84 times the geometrical length of the magnet ठीक है next is magnetic field uniform magnetic field and non-uniform magnetic field हमने इलेक्ट्रोस्टैटिक रे पढ़ी छे तो when a charge is placed in a medium it produce electric field lines it produce electric field lines. जो पर्यंत the field lines will travel, that is called the field of this charge. The space around the charge where the effect can be felt is called electric field of this charge. Again I am saying, যদি ଗୋଟେ charge नबा, the charge will produce electric field lines. जो पर्यंत the field lines will travel, that is called the field of this charge. That is called the field of this charge. Or you can say it is the space around the charge where its effect could be felt. Effect could be felt means यदि आउ गोटे charge आने से field भितरे it will attract or repel. तो similarly यदि हम magnet को देखिबा, a magnet produce magnetic field lines. The magnet produce magnetic field lines. The field lines start from the north pole, ends in the south pole, outside of the magnet. And inside of the magnetic field lines, they travel from south pole to north pole. Okay? So, यदि गोटे magnet नबा, it produce magnetic field lines. जो पर्यंत the field lines will travel, that is called the magnetic field of this magnet. That space around the magnet is called magnetic field. Again, यदि गोटे magnet नबा, the magnet produce magnetic field lines. जो पर्यंत the magnetic field lines will travel, that portion is called magnetic field of the magnet. That field is called magnetic field of the magnet. Say magnetic field ले यदि आउ गोटे magnet रखिबा, there is attraction or repulsion. There is attraction or repulsion depending on the pole position. ठीक है? So we can say what is magnetic field? It is the space around a magnet where its effect could be felt. बुझलो? Next is uniform magnetic field. So uniform magnetic field means if the strength of magnetic field and the direction of magnetic field is constant at every point, then that magnetic field is said to be uniform. Again I am saying, जदि सबु जगह रे the strength of magnetic field and the direction of magnetic field is equal, then we say it is the magnetic field is uniform. Then we say the magnetic field is uniform. These uniform magnetic field lines are represented by parallel lines, equidistance parallel lines. Equidistance parallel line. Equidistance means the distance is same. Equidistance parallel lines. So if we see equidistance parallel line or equidistance magnetic field lines, we say it is a uniform magnetic field where the strength of magnetic field at every point is constant and the direction is also equal. ठीक है? And जदि if the magnetic field lines are perpendicular to the surface, they are represented by equidistance cross or equidistance dots. So they represent this equidistance cross or equidistance dot represent uniform magnetic field. Uniform magnetic field where the magnitude and direction of magnetic field is constant or same. सब जगह रे magnetic field strength समान थिबो and direction मध्य समान थिबो. ठीक है? यदि if you see this, a point रे, a portion रे, the field lines are parallel and equidistant. So we can say A point रे the magnet is having uniform magnetic field. ठीक है. Second is non-uniform magnetic field. Non-uniform magnetic field means the strength at different point is different and the direction is also different. Again I am saying जदि सबु जगह रे the strength of magnetic field and the direction of magnetic field is different, so we can say it is having non-uniform magnetic field. For example, if I say this is diverging lines, or converging field lines. So this is diverging field lines, this is converging field lines. So if you see this diverging field lines, these field lines are not equidistant. So the magnitude or the strength of magnetic field is not same and the direction is also different. They are moving away. They are straight. So different point रे the direction is different and they are not equidistant. So we will say the magnitude and the direction is different at different points. So we say it is non-uniform magnetic field. So similarly converging field lines रे मध्य जो देखिबा ए पोर्शन रे और ए पोर्शन रे तो the field lines are not equidistant and the direction is not same. So we say they are having non-uniform magnetic field lines or non-uniform magnetic field. बुझलो definition लिखियो. Definition: magnetic field, the space around the magnet within which its influence can be experienced is called magnetic field. It is the space around the magnet where its effect could be felt, or it is the space around the magnet within which its influence can be experienced is called magnetic field. Because say field रे यदि आउ गोटे magnet आम आनिबा, the two magnets will repel or attract. Okay. Next is uniform magnetic field. A magnetic field is said to be uniform if it has same magnitude and same direction at all points of the region. Discuss करते हैं. If the magnitude and direction is same, then it is said to be uniform magnetic field. A uniform magnetic field is represented by equidistant parallel lines, or यदि magnetic field टा out of the plane or inward है, say case it is represented by equidistant cross or dots. ठीक है. And last is non-uniform magnetic field. यदि different point रे the strength of magnetic field and direction is different, then it is said to be non-uniform magnetic field. They are we can say a converging field and a diverging field are said to be non-uniform magnetic field because different point रे सेमानकर magnitude और direction different था. Definition is a magnetic field is said to be non-uniform if it has different magnitude at different points. If you see this, so this is diverging field lines. A जगह रे converging. The magnetic fields are moving towards. So it is converging field lines. तो ए दीटा पॉइंट रे the magnetic field is non यूनिफॉर्म. ठीक है.